Okay, these are called distance problems for lesson 98. Now we've already been working with what's been called systems of equations. For example, in the pink here, I have RHTH equals RDTD, and that's one equation. And then I also know that RH is equal to 2 and RD is equal to 4. And what we've done before is, even though this is part of an example, we substituted in what we knew, so we'd substitute 2 in for RH and we'd substitute 4 in for RD, and then we kind of go from there. We're not going to complete this out because this is just an introduction to this, but that's kind of what we've been working with. Now, there's something that's very closely related to distance problems, and that's the distance formula. So a fact that we know is that distance is equal to rate times time. And this is just a fact. So for example, we abbreviate this up. We just call it D is equal to R times T. And to show an example of that, say that you drove at 60 miles an hour and you did that for 2 hours. Well, to figure out the distance that you've gone, well, you take rate times time. Rate is how fast you're going. In driving, it's how fast you're driving. In walking, it might be how fast you're walking, and so on. The time then is just that, how long you do that rate. Now to find the distance in this particular example, you take 60 times 2, and we find out that the distance then would be equal to 120. And in this case, if 60 represents miles per hour, and if time represents hours, then our distance then would be 120 miles. So distance is equal to the rate times time, and this is something that you want to make note of. Now let's take a look at example 1 and let's see how this ties together. It says on Tuesday the express train made the trip in 12 hours. On Wednesday the freight train, now we're talking about two different types of trains here, express train and a freight train. And it says on Wednesday the freight train made the same trip in 16 hours. Find the rate, how fast each of the trains were going if the rate of the freight train was 15 kilometers per hour less than the express. Now, there's a lot of information in this, and what we're talking about is really the express train and the freight train. So what I'm going to do here is that we know that the distance that the freight train, and I'll use F, the distance the freight train went would be equal to the rate that the freight train's going times how long the freight train does that. So again, distance equals rate times time. And you notice I used F to represent this for the freight train. So distance equals rate times time. Now I know that the distance of the express train is equal to the rate that it was going, so how fast it was going, times how long it went at that rate. Alright? Now, it says, let's go back to the problem. On Tuesday, the express train made the trip in 12 hours. Wednesday, the freight train made the same trip in 16 hours. What do you know about the distance of the freight train compared to the distance of the express train? Read the problem. What's it say there? And if you do that, you'll see that the distances are the same. They're talking about the same distance. They're saying that. So I know that the distance of the freight train equals the distance of the express train. These are equal. So I can take this a step further and say then that these are equal. Alright? So I'm going to write that. So I know that the rate of the freight train times the time of the freight train equals the rate of the express train times the time of the express train. So in other words, since the distances are equal, then these are equal. And I've shown that in this equation. Now, you've seen these equations before, right? We've been working with those for the last 10 lessons. So what I have here is we're starting to develop a system of equations. Now what other information is given? See, what I want to do is I want to take this equation and I'd like to narrow it down to how many unknown variables. What have we been stressing? We want to get it to one unknown variable. So let's see if we can do that. What else do we know? It says that the express train made the trip in 12 hours. So what's the time? The time of the express train is 12. What's the time that it took the freight train? 16. So you know what? I know the times. I know these things right here. So I'm going to substitute 12 and 16 in for them. So I have let's see, the time of the freight train was 16. So I have 16 times, I'm going to make that a little neater here. So I have 16 times the rate of the freight train equals, what's the time of the express train? 12, right? So 12 times the rate of the express train. So now I've got this narrowed down to two variables, two unknowns. Now, I have one more piece of information. It says that the rate of each train, it says find the rate of each train if the rate of the freight train, so here's my rate of the freight train, was 15 kilometers per hour less than the express train. So in other words, are the rates of the two trains the same? Are they the same? No, they're not. So again, think of that science balance. And it says the rate of the freight train was 15 kilometers per hour less. So this right here, the rate of the freight train, this side is 15 less. So actually, which side is heavier then? Well, it's this side, because the rate of the freight train was 15 less. So how do we balance it out? Now think about that with our science balance. So 15, this side is 15 less, which means that this side is the side that's weighed down. So what could I do? Well, I could add 15 over here, right? And that's a little twist on the ones that we've been doing here. So again, this side is 15 less. Well, add 15 pounds or whatever you can think of to make this seem to make sense. So my equation then is RE, and I'm going to write it down below here. RE is equal to RF plus 15. Okay? So I know what RE is now. So let's put that in right there. So I have 16 RF equals 12 times whatever RE is, which is RF plus 15. Now let's solve this for RF. And RF stands for the rate of the freight train, or in other words, how fast the freight train was going. So 16 RF equals 12 RF plus, now let's see, 12 times 15, and we'll calculate this out. Placeholder, and what do I get here? 180. Okay, I'm just checking that to make sure that's right. Okay, so let's see, 0, and then I get a 2, yep, so 180. All right, now let's solve this for RF. So I'm going to subtract 12 RF from both sides. That's going to leave me with 4 RF equals 180. Now take 180 and divide it by 4. And I'm running out of room here, so I'm going to erase that. So I'm going to take 180 and divide it by 4. 4 into 18 4 times, which is 16. Remainder of 2 bring down, so 45. So the rate of the freight train was 45. And what unit are we talking about here? Kilometers. So that's kilometers per hour, right? Okay, so I know how fast the freight train was going. Now let's go back to the problem so we can see what else we need to answer. It says find the rate of each train. Now I know that the rate of the freight train was 45, right? How can I find the rate of the express train? Well, I go back to this equation right here. So to find the rate of the express train, take the rate of the freight train, which was 45, and add 15 to it. So the rate of the express train then is equal to 45 plus 15, which is 60 kilometers per hour. All right? So we've answered the problem. Find the rate of each train if the rate of the freight train was 15 kilometers per hour less. So in other words, is the rate of the freight train 15 less than that of the express train? It is. So we found the rate of each. Now let's take a look at one more example. Now, let's just kind of start it here. But it says the members of the girls club hiked to Lake Tenkiller at 2 miles per hour. Mr. Alley gave them a ride back home at 12 miles per hour. So we know how fast the girls hiked, and we know how fast they were driven home. Find their hiking time if it was 5 hours longer than the riding time. How far was it to Lake Tenkiller? All right, so to start this off here, I know that, let's represent the distance hiked. I'll use h equals the rate that they hiked times the time that they hiked. I also know that the distance that they were driven equals the rate they were driven times the time, how long it took to be driven. All right, what do we know about the two distances? Are they the same? Are these the same? So in other words, they hiked to this lake and then they were driven back. So yeah, they are the same. So I know that the rate hiked times the time hiked equals the rate driven times the time driven. So if these are equal, then these are equal. All right, what information do we know? Well, they hiked at 2 miles an hour. So I know that the rate they hiked at, that's a 2. And the rate that they were driven home was 12. So I know that's a 12. So I'm going to rewrite this. So we have 2 RH TH. And excuse me here, we don't need the RH there anymore, because that's what 2 is. All right, so we have 2TH equals 12 TD. What else do we know? Find their hiking time if it was 5 hours longer than their riding time. So in other words, let's make this science balance. Before we do that here, let's see. I know that the time hiked does not equal the time driven, right? So make our science balance. It says that their hiking time was 5 hours longer or more. So in other words, their hiking time, this is 5 more. This is 5 heavier. So how do you balance this out? Well, we got to add 5 over here. So my equation then would be TH equals TD plus 5. All right, so now I know what TH is. So I'm going to substitute that in. So TD plus 5 equals 12 TD. And I solve it for TD, or in other words, the time that it took them to drive back home. So 2 TD plus 10 equals 12 TD. Now I'm going to subtract 2 TD from both sides, so I have 10 equals 10 TD, right? Because I subtracted 2 TD from both sides. Now divide by 10. So the time driven equals 1. Now, what's our unit? Is it hours? Is it minutes? What are we talking about here? It's hours, so 1 hour. It took 1 hour to drive back. All right, let's go back and make sure we're answering all the questions. Find their hiking time. So find their hiking time. How long did it, find their hiking time if it was 5 hours longer. So how can I find the time it took them to hike? Well, right here. So take TD, which is 1, and add 5 to it. So the time that it took them to hike was 1 plus 5, or in other words, 6 hours. 6 hours to hike there, 1 hour to drive back. Now, how can we figure out, and I'll put this in a different color, how far was it to the lake? What's the distance to the lake? Well, I'm going to get that right here, the distance to the lake. So the distance to hike to the lake is the rate that they hiked, which is what? What's the rate they hiked? 2, right? I'll put that right above there. And what's the time that it took them to hike? 6. So I take 2 times 6, 12. So the distance hiked then is 12. Now is it miles? Is it kilometers? What's my unit? Go back to the original problem. It's miles. And now we were able to find out the distance to the lake. Now you could also went back to this equation right here. Because is the distance from the lake back home the same distance as the distance to hike to the lake? Yes, it is. So you could have used that also. All in all, you'll end up with 12 miles. And these are called distance problems.